Hello viewers. In this lecture video, we will discuss about the earthquake resistant design of RC structures. We will also briefly discuss about the earthquake, how they are produced, what types of waves the earthquake produce, effect of earthquakes on building structures, design philosophy for seismic design, and different seismic loading criteria. And finally, we will discuss what are the special ACI provisions for seismic design of RC structures. Earth's interior. This slide summarizes the different layers of Earth that Earth is composed of. On the topmost, there are two different types of crust, which is continental and oceanic. Oceanic crust is found under the oceans and it is about 4 miles thick in most places, and continental varies between 6 to 47 miles in thickness and depending where it is found. Continental crust tends to be much older than the oceanic kind, and rocks found in this kind of crust are often the oldest in the world. And below the crust, we have called a layer mantle, which is further divided into upper, transitional, and lower. Mantle layer is approximately of 3000 kilometers and consists of semi-solid material and mostly iron, magnesium, and calcium at temperature ranges from 1000 degrees to 3000 degrees Celsius. And after mantle, we have a layer called core, which is the most center part of the earth. The outer part of the core is basically liquid, and the inner part is solid. Outer core has a thickness of approximately 2200 kilometers and consists of liquid at a temperature of more than 3500 to 4000 degrees Celsius. And the inner core has a radius of approximately 1250 kilometer, and it is basically a solid material at a very high temperature with very high density and consists of iron and nickel alloy. These layers are then subdivided on the basis of the seismic waves. Researchers have divided the Earth crust into 18 different tectonic plates. Large faults between the Earth crust are formed because of the action of these tectonic plates. Is released associated with the rapid movement of the active faults, and this causes what is called earthquake. Earthquake is the vibration produced by the rapid release of energy from within itself. This release of Earth's stored energy may be due to different phenomena, such as movement of tectonic plates, volcanic eruptions, atomic explosions, or collision of a massive meteorite. This can cause the active faults to rapidly release the energy and cause an earthquake. There are different types of boundaries exist between the tectonic plates and the active fault lines. These are called convergent boundaries, divergent boundary, and transform boundaries. Convergent plate boundary is a location where two of the tectonic plates are moving towards each other, often causing one plate to slide below the other. In the process of subduction, the collision of tectonic plates can result earthquake, volcanoes, and formation of mountains and ecological events. As we can see in this figure, one layer of tectonic plates is moving beneath the other layer. Second type of boundary is called divergent boundary. It is also called a constructive boundary. It exists between the two tectonic plates which are moving away from each other, causing the molten lava and molten magma to come up and construct a new surfaces. So that's why they are also called constructive boundary. Third type of plate boundary is called transform boundaries, as we can see in this third figure. This location is where the two plates slide past one another, which creates and destroys the lithosphere. This is also called the zone of shearing, and this is also one of the reasons for earthquakes. So these are the three major types of boundaries between the tectonic plates, which are the major reason for the earthquake. The energy released from an earthquake travels in form of different waves. These waves then reaches the structure which cause the shaking. Let us discuss different terms of earthquake. Focus or hypocenter. It is a point in the earth crust where basically the earthquake originates. This is called focus or hypocenter. Epicenter. Epicenter is the point on earth's surface directly above the hypocenter or focus. It's called epicenter. Epicentral distance is basically the distance from the epicenter to the place of our interest, like city or any place close near urban place near the epicenter. The depth, the distance from the epicenter to the focus is called focal depth. The type of waves that are originated in an earthquake can be classified majorly in body waves and surface waves. Body waves, when travel through the interior of Earth's surface, reaches the surface of Earth, can be then transferred into the surface waves. There are two types of body waves: P waves or S waves. P waves is also called primary waves, and in this, particle movement is parallel to the direction of movement, propagation of wave. P waves travel 1.73 times faster than the other waves. These waves do not cause much damage. S waves. S waves are called shear waves. In this, particle is moved perpendicular to the direction of propagation. When these body waves reaches the surface, they are converted into surface waves. Then further surface waves are divided into two types of waves: love waves and Rayleigh waves. Love waves. Love wave move horizontally in the direction of propagation of wave. They are basically the result of many shear waves interference. Rayleigh waves produce a circular motion like ocean waves. The rotation along with the vertical movement take place in our waves. So these are two types of surface waves. Types of earthquake. Earthquake with respect to depth of focus can be classified into shallow earthquake where the depth of focus varies from 0 to 70 km, and deep earthquake can be classified where the depth of focus is from 70 to 700 km. Second type, earthquake with respect to the distance from the epicenter. They can be classified into near field where the epicenter from our area of interest is 0 to 25 km, intermediate field and distance from the epicenter is 25 to 50 km, and far field, which is area of interest, has a distance more than 50 km from the epicenter. Further, earthquake can also be divided with respect to its duration. Short duration earthquake, like 4 to 2 seconds earthquake, these can be more destructive for shorter period of uh, structure. And long duration earthquake, which are up to 30 seconds or more than 30 seconds, can be of low intensity. This figure shows the different types of earthquake from the epicenter. Resonance risk of structure with respect to time period of an earthquake. The natural time period of structure is an important characteristic to predict the behavior during an earthquake of a certain period. This is called basically the resonance phenomena. When the earthquake have a shorter period, it can cause the destruction to the shorter period structures like small structures. When the period of an earthquake is long, then they can cause the structure damage to the large building because they have a longer natural period. So this is basically called the resonance phenomena. Similarly, the resonance phenomena can also can also occur with respect to the location of the epicenter. Like in this figure, we can see if the epicenter is closer to the low rise, because at this point the the period of an earthquake will be shorter and it will cause much more damage to low rise. Similarly, that it can goes to the medium rise structure and then high rise structures. Recording of an earthquake. To measure the amount of destruction caused by an earthquake can be measured in two terms. One, earthquake magnitude, and another is earthquake intensity. They both are different. Earthquake magnitude is the amount of energy released during an earthquake. It defines the size of the seismic event and not related to the damage or effect of an earthquake on a given location. It is measured by a Richter scale, which is developed by Charles Richter. So, in the Richter scale is a logarithmic scale, which means the magnitude 5 Richter is 10 times greater than the magnitude 4. The instrument used to record an earthquake is called seismograph. These are different seismographs which are used to record an earthquake and create a graph which is called accelerogram or accelerogram. This shows the amount of energy released by an earthquake. Earthquake intensity is an assessment of the effect of an earthquake on a given location, on a building or other structures in human life. This is called Mercalli scale or Mercalli index. It can be divided into 12 parts like 1, 2, 3, 4, 5, 6, 7, and then we can also have some kind of correlation with the magnitude. Like Mercalli scale 1 can be caused by an earthquake with the magnitude of 1 or 2. This is felt by very few people, barely noticeable. Similarly, like Mercalli scale 5 can caused by an earthquake 4 or 5, felt almost by everyone, and some people awaken, small object moved, and trees poles may get shaken. Similarly, the maximum damage which can be caused by an earthquake of magnitude 8, which have a total damage of a community, and few structures are remaining standing. So this means that there can be an earthquake of 8 magnitude, but it doesn't mean that it will have a Mercalli scale of 12 or 10, because if it's very far from any community or an urban area, it will not cause a huge damage. So there is not an accurate relation between the Mercalli scale and the Richter scale, but this is a general representation. This chart shows the notable earthquake and the equivalent amount of energy released. As we can see that there are different earthquakes like Chile earthquake, Alaska, Japan, New Madrid, San Francisco, Loma Prieta, Kobe, Northridge, Long Island, and this is the amount of Hiroshima atomic bomb amount of energy released, and the is approximately equal to the amount of energy released by an earthquake in Northridge. So these are the magnitudes and this is the energy released. So we can see the amount of energy is huge when an earthquake occurs. That's why it can be very destructive for the building structures or a city or any community. This slide shows the different seismic zonation of Pakistan. There are few areas which comes under zone 4 like this northern part and southwest part. These are the areas with the high seismic activities. Then further it can be classified into zone 3, zone 2B, zone 2A and zone 1 where very less earthquake occurs. So design of a building structure will depend on the zone in which you are designing a structure. Effects of earthquakes on buildings. The earthquake vibration causes displacement of structure because of inertia forces that is induced in the building. It means that when the earthquake happens, the amount of the energy released from the earthquake reaches some nearby community or urban city, and that energy is induced into the building structures or inputted into the building structure. This caused a sudden vibration in the building structures, and this effect of inertia in the buildings causes them to shake. As we can see in this figure, if the earthquake causes the building structure to move in this direction, the upper part of the structure will remain at its rest position. This is called inertial forces. So, this is another example of inertial forces relative to its motion. Earthquake causes the ground shaking in all three directions X, Y, and Z. Normally, the structure designed for gravity loading is satisfactory for vertical component of an earthquake. The structure are normally designed for lateral forces so that it can minimize the effect of damages due to earthquake and it can reduce the displacement. Causes of collapse of building structures in an earthquake. Remember, earthquake itself do not cause destruction or collapse of the building structures or any civil structures. The major problem or the major reason that the building or a civil structure collapse is because of different errors that we make in design. We will discuss different causes of collapse of building structure in an earthquake. Number 1. Ignorance of design codes. Ignoring the seismic provision by the architects or inexperienced structural engineers provided in the building codes can be one of the reasons. If the building is designed in a high seismic zone without a seismic design, it can cause the collapse during the structure during an earthquake. Softness of base soil. The investigation of soil is very important and very essential in case of design of building structures in a high seismic zone. Earthquake can cause the amplification of ground motion at the base. In the absence of the plinth wave, it can cause a differential settlement. And if the soil is sandy or water table is high, it may also liquefy. The soil exploration at the building site must be carried out at sufficient points and at sufficient depths. Soil classification in various steps of soil and properties like grain size, distribution, field density, angle of internal friction, cohesion, and plastic and liquid limits should also be uh, taken considered into the design. Position of water table is also one of the very important factor when designing a structure in a high seismic zone. Number third, bad structural system. For instance, floating column is very undesirable in moderate to high seismic intensity seismic zones like 3 or 4. This is an example of a floating column. Due to huge lateral loads and eccentricities in the floating column, they can simply collapse. Another major reason for collapse of building structure is having a soft story in a building structure. Open ground story or intermediate soft story without brick masonry infills in an RC building experience severe damage during an earthquake. Soft story introduce irregularity or sudden change of stiffnesses are the buildings which have collapsed due to soft story. This slide shows the soft story building. Like there are no infill walls at this ground floor level, and there is a huge mass on top of this columns only. And when an earthquake comes, due to this mass, higher inertia, it can cause the collapse of these columns, and then it can cause the collapse of a whole structure. To avoid soft story, there are different techniques. Either we should provide the proper shear walls, bracing of columns in the soft story, large sections for columns, or providing the infill walls between the columns. And we should avoid such kind of soft stories in building structures. Another reason for the collapse of building structures is due to some of the architectural features. The behavior of a building during an earthquake depends critically on its overall shape, size, geometry, in addition how the earthquake forces are induced in the building. Simple plan buildings are much more appropriate as compared to the irregular buildings because if there are some irregularities in a building structure, it can cause the stiffness of overall building structures to move away from its center of mass, and hence it can cause huge torsion and eccentricities, which can cause huge displacement in the structures. We can see different kind of building structures, and in this figure we can see the shear wall is being provided at one end. However, the other sides of the building structures are having a less columns. It can cause a torsion effect in a building structure. Pounding damages to an adjacent building or pounding effect. Pounding effect can cause a severe impact on two buildings which are adjacent to each other without an improper gap. When an earthquake comes and shaking of these buildings can cause a huge mass to stuck together, and this can cause a huge destruction on either of the buildings. Reasons of collapse of building structures may be poor construction quality, improper detailing of reinforcement, dimensions of column and beams, heavy water tanks or machinery on roofs, lack of earthquake design in existing structures. These are the building structures that have been collapsed due to an earthquake. As we can see the soft story effect, and we can also see the with improper detailing of the columns can cause the collapse of column. Next video shows the earthquake effect on a hospital building. It's an experimental setup.